Welcome back, friends, and today we are going to continue with our topic of volumetric analysis. If you remember, in the previous session we were in the demonstration of some of the concept of volumetric analysis, and if you were together with me, we discussed about the calculation of molarity of a substance. In volumetric analysis, we said that one among the types of calculation, you can calculate molarity of the substance. And if you remember, we used this example from our notes here. We used this example for calculating the molarity of a substance, and we said that we had defined the relative atomic mass of a known element. However, for this case, it was not the relative atomic mass of a known element, but it was the molarity of a known substance. Kwa hiyo in form 3 chemistry nilisema kwamba kuna 4 types of volumetric analysis calculations. Kwanza lazima ujue how to calculate molarity. Ukishajua how to calculate molarity, calculating molarity ndo basic. Ukijua calculate molarity, hizo nyingine unatumia calculation hizi za molarity. So from there utaenda kujua jinsi gani calculate the relative atomic mass of a known element. From there utaenda kujua calculating the percentage purity, and then last utajua kuhusu calculation the rate of crystallization of a substance. Kwa hiyo don't worry, in this channel later we will discuss about the different questions in the NECTA exams. Some of them will be theory questions, some of them will be practical questions, but all of them, they aim to train you so that you will be able to solve different questions in volumetric analysis and different topics of Form 3 chemistry, Form 4 chemistry, biology, physics and mathematics. So just stay tuned, and by subscribing to the channel you'll be able to get updates of different sessions. So we calculated this question, and we ended up with this answer 0.25 m, and we used the acid-base molar ratio as how I demonstrated in the previous session. So kwenye hii session nitakuwa naelezea notes, lakini kwenye kipindi vinafuata nitakuwa nafanya demonstration. So naelezea notes, then naenda kufanya demonstration ya calculation. Naelezea notes, naenda kufanya demonstration. And I hope by this way it will be very easy for you to understand and even to cope with the concepts, and at the end of the day to be able to solve many of the questions in your Form 3 chemistry and even in your O-level chemistry and even in your advanced chemistry, because these concepts, they are actually they are seen as the O-level concepts, but they are used even in advanced level to solve different questions regarding chemistry. Kwa hiyo kilichopo ni kwamba hapo tutadiscuss leo, nataka tukadiscuss kuhusu calculation of the relative atomic mass of a known element in acid or alkali. So here ni kwamba unakuwa umepewa an acid. Let's say the acid is not known its name actually, but what is known is just one element. Let's say it's the HCl, but it is written as HX. So if it is HX, it means you don't know X. So for the case titration, most of the time HX can be just regarded as HCl, kwa sababu tayari unajua kwamba acid pekee yenye element moja ni hydrochloric. Nitric has HNO3, then sulfuric has H2SO4. So for this case ninachomaanisha ni kwamba most often unakuwa unapewa swali la base. So let's say you are given XOH, and this XOH you don't know whether it's sodium hydroxide or whether it's potassium hydroxide. By using the calculations of volumetric analysis, first by titration, and then after titrating you will draw the table of results. After drawing the table of results, you will calculate the average volume of acid. After calculating the average volume of acid, then you will calculate the relative atomic mass of the whole element. Let's say it's a base or it's an acid. And after calculating that relative atomic mass of a base or an acid, then later you can calculate the relative atomic mass of an element. And lastly, you can state even the name of the element, the symbol of the element, its position in the periodic table, regarding on the extent that a teacher has asked you in your question. Kwa sababu walimu mbalimbali wanauliza maswali sawa sawa na wao ambao wanakuwa wanataka kukuuliza wewe kwenye huo mtihani wako. Now let's start our discussion by discussing this concept of calculation of relative atomic mass of an element. So tunapoanzia ni hapo kwenye hili swali la pili. Tunaanza hapo kwenye swali la pili. Just stay tuned, I hope you understand me. Now calculating the relative atomic mass of an element in acid or alkali. Now here we are given one example, and we will use this example to solve the question. So later I will demonstrate it in a paper, and after demonstrating it in a paper, I hope it will be very easy for you to understand what I'm talking about now. If you don't understand now, don't worry, when you will be demonstrating it, I hope you will understand. Now we are saying that find the relative atomic mass of a known element in acid or alcohol. For example, we are given in this question, in this question, which is an example, we are given 20 cm cube of solution containing 7 gram per dm cube of a metal hydroxide, XOH, and we don't know this metal hydroxide, it is whether potassium or sodium hydroxide. We are exactly neutralized with 25 cm cube of 0.1 m hydrochloric acid. You see, so already here we have volume of a base. We are given, let me just write my data here. We are given volume of base. Volume of base is equal to 20 cm cube. It is 20. Then we are given this 7 gram per dm cube of metal hydroxide, means this is concentration of base. Hydroxide compound is base. So concentration of base, this will be equal to 7. So I don't write the unit here because we know the unit of these measurements. We exactly neutralized, you see, 25 cm cube of 0.1 hydrochloric acid. So we know our volume of acid is equal to 25. Volume of acid is equal to 25, and after that we have the molarity of acid, which is here. So molarity, it is m of acid. Molarity of acid is equal to 0.1, and we know for this base it is X hydroxide. And from there also we know the acid is HCl. So we have this detail, we have this data, and we want to use this to calculate the relative atomic mass of an unknown element, which is X. Now what we are saying first, we need to write the balanced chemical equation between the metal hydroxide and HCl. And for this case, we have the metal hydroxide XOH. So we are just writing XOH, XOH plus HCl. So it is XOH plus HCl and then from XOH plus HCl we are getting XCl X chloride plus water. Now according to this equation, if we balance the number of moles, if you balance the equation, if you balance it, then later at the end of the day you end up with the number of moles of acid and base. All of them will be 1. The balanced chemical equation, it is seen here, however it's not clear, but as you can see, HCl, it is aqueous plus X hydroxide, is aqueous, then you get X chloride, which is aqueous plus water, which is liquid. So at the end of the day you will get the number of moles of acid, Na will be equal to 1, and then number of moles of base Nb will be equal to 1. So don't worry if you don't know how to calculate these number of moles of acid and number of moles of base. You can view my previous lectures, but if you don't have time, we are just looking at the balanced chemical equation, and then we are looking the number before X. So here it is 1 and here it is 1 if you balance it. Now from there we are using the Mlelwa formula to calculate the molarity of base. What we need here is the molarity of base. So as we know, in our normal Mlelwa formula, we are calculating the molarity of base, and after calculating the molarity of base here, we can continue with the calculating other parameters in a base. So from our normal Mavana formula, calculating the molality of base, we will say, let me demonstrate here what I am talking about. Calculating the molality of base, calculating molality of base from our normal formula. So we are saying from our formula, it is MA. From our formula, it is MA times VA, then divided by MB times VB is equal to number of moles of acid times number of moles of base. Okay, sorry for that. And number of moles, what I meant here, it was times number of moles of base. So this is our Mavana formula, and then from there we are calculating molality of base. So molality of base will be equal to molality of acid times volume of acid times number of moles of base divided by molality, volume of base, number of moles of acid. So doing that calculation, utakuja kupata jibu lako la mwisho la molality of base. Utapata ni hapo calculate molality of acid. Tufanye calculation. Molality of acid tupewa 0.1 times C. Volume of acid tupewa ni 25 times C. Number of moles of acid ni 1, hiyo ganya kwa 20 mara 20 kwa utapata ni kama 2.5 ganya kwa 20. 2.5 ganya kwa 20 utapata ni kama 0. I don't know the exact answer hapo. 0. hapo 2.5 ganya kwa 20. Ngoja 2 ganya kwa 20 hapo utapata 0.20 itaingia kwa 1. 50 itaingia kwa 2. So itakuwa ni kama 0. Ni 0.12, then itabakia 5. 0.125. So molality of base will be equal to 0.125. From there tunaenda kutumia formula ambayo tunaifahamu. Tunaenda kutumia formula ambayo tunaifahamu, and the formula which we are using here, is the formula of molality ambayo tunaifahamu every day. So tunaenda kusema kwamba molality is equal to concentration divided by nini? Molar mass. But remember here, concentration of base we have, and molality we have. So what we are calculating? We are calculating the molar mass. So from there we are just saying molar mass will be equal to concentration divided by what? By molality M. So from there molar mass will be equal to concentration tulipata ngapi? Yawe base tulipewa pale ni 7. So it is 7 gram per dm cube. And then tunagawanya kwa ngapi? Tunagawanya kwa 0.125. Kwa ukigawanya hapo, let's say hapo ukigawanya utapata molar mass of the wool compound, molar mass is equal to, kwa sasa hapo kidogo na unatakiwa wewe uko vizuri kwenye calculation. Hii maana yake ni 7 gawanya kwa 125. So 7 gawanya kwa 125 hapo unaweza ka cancel baadhi ya measurement, ukaanza kukata kwa 2 kwa 2 kwa 5 vyote hivi. Kwa mfano 7 ukikata kwa 5 utapata ngapi, na hapo ukikata kwa 5. Lakini at the end of the day lazima uje kupata molar mass of the compound. So for my case, let me use my calculator here. Tuone napata jibu ngapi. Bani nitumie calculator hapa. Kidogo bongo sasa huwezi kufanya calculation kwa kichwa, ila natumia calculator. Kwa napata 7 gawanya kwa 0 kwa 0.1 0.125 0.125 utapata ni 56 exactly. Kwa maana kama tu uko vizuri kwenye mathematics hapo utapata 56 exactly. Now 56 is the molar mass of the wool compound. 56 is the molar mass of the wool compound. That means X or H is equal to ngapi? Is equal to 56. But remember, you know the molar mass of oxygen and hydrogen. So you are finding for X. That means molar mass of X plus molar mass of oxygen, which is 16, then plus molar mass of hydrogen, which is 1, is equal to ngapi? Is equal to 56. So saying so manake hapa ni 17. So it is X is equal to 56 minus 17. From there the final answer ambayo tutakuja kuipata hapo 56 toa 17, X utapata sana ngapi? Na 39. And we know 39 ni nini? This is the relative atomic mass of what? Of potassium. So hiyo ndio final answer ambayo umeipata hapo. Kwa kwenye notes unaweza kuona kama haina maelezo vizuri, lakini hivyo ndivyo ambavyo wameifanya hiyo calculation. I will demonstrate this well in the next session. So you will see it in a paper and it will be very well explained. So don't miss to see the next session. I will demonstrate this calculation in the paper and you will see it very well. Nimeanza na hapa kwenye notes ili uone kwamba how the question appears. And don't worry, we will solve the questions of volumetric analysis and the other topics, many of these, so as to make sure that you are competent in your chemistry, biology, physics and mathematics. So for this time we'll start launching many sessions in the O-level and many advanced science subjects, so as to make sure that your performance is going well. So for this session, let I wish you the nice studies, and not forget to subscribe to the channel and to share the link of this channel to your fellow students. This is the very good site, the best site for you to learn different concepts, and this is the best site for the better performance of your NECTA exams and all other kinds of exams which you can be performing, let's say the mock exams of different zones. Kwa ukiweza vizuri kuelewa concepts, kuna cha EZEB, kuna cha Tamongosco, all kind of the exams, you can afford to get A of those exams. So thank you everybody. The presenter in this session, I am Dr. Mlelwa, and let me wish you nice studies.